first algorithm that we have to study today is priority scheduling. This is actually very simple, and it's exactly like FCFS, first come first serve, except that now every process has a priority associated with it. So the processes which are more important have higher priorities, while the other processes which are not that important have lower priorities. So any process which has higher priority will be executed first, and the processes which have lower priorities will be executed later. The question now comes is, what happens if two processes or more than one process have equal priority, same priority? What will happen then? So in that case, they will be scheduled in FCFS order. That means in case of same priority, whichever process comes first will be executed first. Now let's see this algorithm in a little bit more detail. Let's say we have four processes, P1, P2, P3, and P4. And let's write their execution times, or the service time, which we read last time. That execution time, service time, burst time, they're all the same things. So let's say this process has an execution time of 2, maybe this has an execution time of 5, let's say this has 1, and let's say this one has 3. And since we are studying priority scheduling, every process will have some priority associated with it. So let's say this process has a priority of 3, this process has a priority of maybe 1, and this process has a priority of 2, while this process has a priority of 4. Let's say, just let's assume that. Also, let's say that 1 is the highest priority. So we can do it the other way too. That we can also say that 10 is the highest. It depends on us. So right now we are saying that 1 is the highest priority and 10 is the lowest priority, if we are numbering it from 1 to 10. Now, how will these processes be scheduled or run using this priority scheduling algorithm? So first of all, what will happen is we have to execute them in the order of their priorities. And if we are saying that 1 is highest and 10 is lowest, that means the process with the highest priority will be 1. The second highest priority will be 2. The third highest will be 3, and the fourth highest will be 4. So this should be their execution order. So for that, an easier way is to sort them on the basis of this. So this is priority and this is their service time. So the best thing or the easiest thing will be to sort all these algorithms, all these processes on the basis of their priority, and this is their priority. So it will be better to sort them according to this, and sort them in ascending order, because we are saying that 1 is highest and 10 is lowest. So sort them and then they will run in the FCFS order. So let's sort them and write them here in the sorted way, in the ascending order of their priorities. So first of all, we will write 5 here, which is P2. Why? Because let's make another box here and write priorities here. So it has the priority 1, so that means it will come first. The second one will be obviously 3, because the second highest priority is this. Second highest priority is 2 right now. So it will be executed afterwards. The third process which will be executed will be this process. And it has a service time of 2. This is process P1, and the priority is 3. And the fourth priority, this process, right? So we will write 3 here, and this is the fourth process. So this is the order in which these processes will run if they are scheduled by the priority scheduling algorithm. And now, since we have sorted them and this is their execution order, now we can calculate all those times which we calculated last time. They were waiting time and total time. So we can write that for each of these processes. So for the first process, waiting time is 0. We discussed that. The first process doesn't have to wait for any other process. That means its waiting time will be 0. The waiting time of second process will be the execution time of first process, right? The waiting time of second process is always the execution time of first process, because it has to wait for this amount of time to run. So the second process, which is actually P3, it will run on the second number. Its waiting time will be 5. The waiting time of third process, which is P1, will have the waiting time of the sum of these two processes. So 5 plus 1, it will have the waiting time of 6, and the waiting time of fourth process, P4, will be executed, will have the waiting time of equal to the sum of these three processes. So P4 will have the waiting time which is equal to the sum of these three, which will be equal to 5 plus 1 plus 2. So 5 plus 1 is 6 plus 2 is 8. So it will have 8. Now let's come to the total times. So total time is always equal to service time plus waiting time. The total time is equal to the total amount of time that this process has to spend in the queue. So that time is equal to its own service time plus the time it waited for the other processes. So it will be equal to 5 plus 0, which is equals to 5 in this case. Okay, in the second case, in the process P3, in that case, that will be equal to 1, the service time of its own, and 5, the time that it waited for others. So 5 plus 1 is equals to 6, and in the case of third process, it will be equal to 2 plus 6, which is equals to 8, and for the last process, it will be equal to the service time 3 plus the waiting time 8. So 8 plus 3 equals to 11. So this is how you do it.